Sometimes we'll want to make a solution that's so dilute that it would be impractical to do just one dilution for. You'd have to measure too small of a volume. Sometimes we want to make multiple concentrations to use in our experiments, so we can test all those different concentrations. For example, we might want to find the best dose of a drug. In each of those cases, we would want to do a serial or sequential dilution. With serial dilutions, we're going to have a stock solution to begin with, and we will take some out of it and put it into a new test tube or vial or flask that has some liquid in it to make our first dilution. Then that becomes our new stock to draw from. We take some out of that new vial and put it into yet another one and dilute it. Vial 2 becomes our new stock, so we take some out of that and put it into a new vial and dilute it. This technique is used in chemistry. It's also used in biology for plating out bacteria. Usually, bacteria solutions are too concentrated to plate directly. If you did so, the bacteria would just grow together into one big smudge, and you wouldn't be able to count the colonies or circular growths of bacteria, which is something that microbiologists or other types of biologists do pretty frequently. In fact, I did it all the time in my research in graduate school. In order to get the separate colonies, the concentration has to be appropriate. We could take 1 milliliter out of the stock, put it in with 9 milliliters of the broth that you're incubating the bacteria in, and that would create the first dilution. Then you can take 1 milliliter out of that and put it into 9 milliliters of broth in test tube number 2. That next bacterial solution is going to be less concentrated, and then the one after that will be less concentrated than that one. Each time the solution is becoming 10 times less concentrated than the one before it. Eventually, you get to a test tube that's dilute enough to where you can see the individual colonies. You may not actually know until you stick the plates in the oven overnight which one is going to give you the best result. Doing it as a serial dilution and plating all of them will give you a chance to have one that is optimal with a really good amount of colonies that you can count properly, and you'll only have to wait one night for all your plates to grow the bacteria. To do our calculations for serial dilutions, we're going to have our initial stock solution, which would be our C1, and we would solve for C2, the new concentration. After that first dilution, then that C2 from the first dilution becomes the C1 in our next calculation, because it becomes the new stock. We just do this calculation for however many new vials that we're calculating it for. We can find the concentration of each one of them. Let's look at an example. We're trying to find the concentrations of each of these new standard solutions that we're trying to prepare. We call them standard solutions because they will be of known concentration once we've made them. We've got our original stock solution and then these 4 standard solutions that we're making, which are separate from the stock solution. We're taking 10 milliliters out of each solution, putting it into the next flask, and diluting the rest of the way to 250 milliliters. First, we take 10 milliliters out of our original stock, which was 2 molar, and put it into our first flask, and then dilute to the line with water. We shake it up with the top covered to make sure it is evenly mixed. Next, we take 10 milliliters out of flask number 1 and put it into flask number 2, then dilute to the line with water and shake it to mix. Then we take 10 milliliters out of the second flask and put it into the third flask, dilute to the line with water and shake to mix. Finally, we take 10 milliliters out of the third flask and put it into the fourth flask, dilute to the line with water and shake it to mix. Here's how we do the calculations to find what the concentration is for each of those flasks. We're using our dilution equation, C1V1 equals C2V2. But again, we're going to rearrange it to solve for the variable that we need. In this case, the variable we need is the concentration of each new solution, C2. To find each concentration, we're going to use the rearrangement C2 equals C1V1 over V2. For our first flask, C1 is our original stock solution of 2 molar, and V1 is the initial volume that we're taking out of the stock and putting into the new flask, which is 10 milliliters. V2 is the new volume that we are creating of the diluted solution, which is 250 milliliters. We do 2 times 10 divided by 250, and that gives us a concentration of 8 times 10 to the minus 2 molar for our first volumetric flask. Our second volumetric flask is going to be calculated the same way, but we're not taking out of our original 2 molar stock. Instead, we're taking out of our first flask that we created. C1 in this case, the concentration that we're taking out of, is 8 times 10 to the minus 2 molar. The other variables are the same. We're doing 10 milliliters each time, and we're diluting to 250 milliliters each time. Really, the only thing that's changing in this example is the concentration of the solution that we're pulling from. When we do that calculation, we find that the molarity in flask number 2 is 3.20 times 10 to the minus 3 molar. For flask number 3, we're plugging in that 3.20 times 10 to the minus 3 molar as our C1, and we come out with 1.28 times 10 to the minus 4 molar as our C2. That is the concentration of flask number 3. Flask number 4 ends up with a concentration of 5.12 times 10 to the minus 6 molar.